Welcome back, all my aspiring mathematicians. Today, I am going to discuss with you how to find the perimeter of a given object. But guess what? This object does not have any measurements. And in order to find the perimeter of a given object, we need some measurements. But let's think. How are we going to do that? Guess what is given? You are given the coordinates. And once you're given the coordinates, you will be able to find the perimeter of that object. So before we get started, let's define a perimeter. So a perimeter is the total distance around the outside of a two-dimensional figure. And that figure is two-dimensional because we are dealing with two units of measurements. We are dealing with the length and the width. So let's first deduce the word perimeter. From the word perimeter, there is a prefix peri, which simply means that it is around or it is enclosing. Also from the word perimeter, in the middle, you will see the word rim. Rim is simply talking about the edge. So if you think of the rim for your bicycle or the rim for your car rims, you're talking about a circular thing that has a distance around it. So you're talking about the rim, the edge. All right. So if you see the word rim, you're talking about the edge. We also know that if we are finding the perimeter of a figure, whether it is a rectangle, right, or a quadrilateral, you have four measurements. And because you have four measurements, sometimes all the measurement is going to be the same, which would be a square, or it could be a situation where opposite sides of the measurements are going to be congruent, and then that would be a rectangle. But there's also a scenario where not all the time you're going to deal with the perimeter of a square or the perimeter of a rectangle. You can have a quadrilateral that is not a rectangle, but you also might end up with either having four of the sides that are going to be totally different, or you still can have two congruent sides, but those two congruent sides are not going to be opposite each other. So with that being said, there are two ways of finding the perimeter of a quadrilateral without any measurements. What are the two ways? First, you can use the distance formula to find the length of all of the segments. Okay? The second method, I'm going to show you, but you have to be patient. That method is the simplest and easiest method, and you are going to apply the Pythagorean theorem formula. So let's get into the lesson on how to go about finding the perimeter of a quadrilateral without any measurements. So let's do it. Let's do it. Let's do it. So before we get started, there are two ways that we can find the distance around the given figure. And I'm going to show you each method step by step. The first method is to use the distance formula. Let's get right into the first example. In this example, you will be given the measurements. The coordinates are for A is going to be 2, 5, and for B is going to be 4, 7. For C it's going to be 7, 4, and for D it's going to be 5, 2. So now that you are given these coordinates, we have to take it to the graph paper and we're going to plot these points. So let's get started with plotting the points. So the first point is A is at 2, 5, and please do not tell me that you're going to start on the y-axis with finding 2 and going on to 5. Please don't make that mistake. A is 2, 5. You're going to go along the x-axis, and you can label this as x-axis for those students who are not versed in math, and this would be your y-axis here. So x is 2 and then 5, so this is your point for A. Now B is 4, 7. So B is 4, 7. This is B. And then for C, it is 7, 4, which is right here on the edge. And then for D, it is 5, 2. So once you have the points plotted, you can now go ahead and connect your points to form your quadrilateral. Right. This is what the polygon looks like after you have plotted the points, and now you have 4 vertices there. You will note that you don't have any measurements. So how am I going to find the perimeter around this? You need to have the measurement to be able to get the total distance that is going around the edge of this 4-sided figure. So what we're going to do first, we are going to apply the distance formula. And yes, we have the distance formula, and the distance formula is simply that D is going to be the square root of x2 minus x1 to the second power plus y2 minus y1 to the second power. So you're finding the square root of all of these. What I would suggest for you to do is to first find the lengths of each of the 4 sides of that figure. We're going to start with segment AB, and we're going to label this as x1, y1, x2, y2 in this case. So segment AB is going to be finding the square root of x2 is 4 minus x1, which is 2, raise that to the second power, plus y2 is 7 minus 5, raise that to the second power. So the length of AB is going to be the square root of 4 minus 2 is going to be 2 to the second power, plus 7 minus 5 is also going to be 2 to the second power. So segment AB is going to be the square root of 2 to the second power is 4 plus 4. So segment AB is going to be the square root of 8. Now, you can leave your measurement as this, or you can break it down, but I prefer to break it down. And if you need help on how to break down or simplify radicals, you can go back and watch my video on how to add and subtract radicals. So now you will have AB, segment AB is going to be a perfect square first, which would be square root of 4 and square root of 2. So segment AB is going to be 2 radical 2. And that's for your segment there. You're not finished. That is only AB. We need to now find what BC is going to be. And so segment BC, which is that long segment there, we are going to label each of the coordinates first. From the formula, which is x2 minus y1, we have x2 here, which is 7. 7 minus x1, which is 4, so 7 minus 4 raised to the second power, plus y2 is 4, and y1 is 7, so raise that to the second power. Now we have segment BC is going to be the square root of 7 minus 4, which is 3 to the second power, plus the square root of negative 3 here. So if you're not versed with your negative numbers, please practice on your negative numbers. If you are working with negative numbers, I would suggest that you think of your negative numbers as you owing someone some money, and then your positive number as someone gave you some money. For instance, you owe your brother $7 and then your sister gave you $4. After you've paid the debt, you still owe your brother $3. So think of it that way. So let's continue. Segment BC is now going to be 3 to the second power, and please, it's 3 to the second power, not 3 times 2, so please don't make that mistake. 3 to the second power simply is telling you that you're going to multiply 3 2 times or by itself, okay? Not 3 to the second power does not mean that you're going to do 3 times 2. No, that is incorrect, because that would be 6, and 6 is not what you need to have here. So 3 to the second power is 9, plus negative 3 to the second power is also going to be a positive number, because negative times negative is going to be a positive number. So you have 9. And then you have to add that. So now you have the square root of 18. Now the square root of 18 can be further broken down into a perfect square and a non-perfect square. So if you break this down, you will get radical 9 and radical 2. So segment BC is going to be 3 radical 2. And that's your answer for that segment of that side. So we need to find segment CD or segment DC now, and that's the next one that we need to find. I'm going to find segment CD. So segment CD, and we're using the distance formula again, but please go back now and label this accordingly. So CD, we have here our x1, y1, x2, y2. We don't want to make any mistakes, so please label accordingly. If you need more help on working with the distance formula, you can go back and watch my video on the distance formula. We have here x2 is 5 minus 7 raised to the second power plus 2 minus 4 raised to the second power. And we have segment CD is equal to square root of -2, because 5 minus 7 is -2 to the second power, plus 2 minus 4 is -2 to the second power. And you will still end up with 4 right here plus 4. So CD is equals to square root of 8. And you can break down that to square root of 4 and square root of 2, which CD is going to give you 2 radical 2. So you have that. So you need a last measurement, which is now AD. And I can almost tell you straight off the top that is going to be the same as 3 radical 2, but let's put it to work. So you're going to find now segment AD, all right? And you are going to use A and D. So it's already labeled as x1, y1, x2, y2 right here. So you will use those. And D, x2 is 5 minus 2 to the second power plus y2, which is 2 minus 5 to the second power. So AD is going to be square root of, this is going to be 3 because 5 minus 2 is 3 to the second power, plus this is going to be -3 to the second power. Please put it in parentheses so you don't make any mistake there. Segment AD is going to be 3 to the second power is 9 plus -3 to the second power is also 9. Now I must say to you as a sidebar that -3 to the second power, once you have it in the parentheses, is totally different from when you have simply just negative and then 3 to the second power. There's a difference there. All right, -3 to the second power is this, but if you have it like this, or even with the parentheses around it, this is going to be -9, and this will give you 9. So be careful when you're writing that. That's a sidebar. So segment AD is going to be square root of 18, and you further break that down to radical 9 and radical 2. So AD is equal to 3 radical 2. So we're not done. We have our 4 lengths right here. I'm going to write them along the sides of the figure. So AD is 2 radical 2, and BC is 3 radical 2, and the DC is the same, 2 radical 2, and AD, which is 3 radical 2. Therefore, if we are finding the parameter of a given figure like this, and we also know that the formula for the parameter of a figure like this, which this is actually a rectangle, which means that opposite sides are congruent and opposite sides are also parallel to each other. That's the property of a rectangle. With that being said, we can also apply the regular formula for a parameter. In this case, now that we have identified that this is a rectangle and we have all the four measurements, and the opposite measurements of each side are congruent. Further, use the regular perimeter formula for a rectangle, which is finding the length twice, adding that to the width twice, or we can simply say that we can use the perimeter of a rectangle, which is going to be length plus the width times 2. Okay, or you can see 2L, which is a length, plus 2 width. Either one is going to be fine, and that's of a rectangle. We're going to add these measurements that we have so we can find the perimeter of this rectangle. So the perimeter of, and I'm going to draw just a symbol of a rectangle instead of writing out the words. You can do that. 2 radical 2 plus 3 radical 2 plus 2 radical 2 plus 3 radical 2. So an easy way to add this is that we notice that the radical 2 are common, right? The common terms here. So we can take out the radical 2, and then we will have 2 plus 3 plus 2 plus 3 inside, all right? And that's P. So P is equal to radical 2. You have to add what is inside, and this is going to give you 10. So P is equal to 10 radical 2. You always write it like this because you don't want to have the number after the radical symbol. Same thing applies for when you're writing variables. You don't write W3, you write 3W. Now, if you want to further simplify this, it is fine. You can go ahead and further simplify this by, on your calculator, you hit what is square root of 2 first, and then after you get that, then you hit times 10, and you will end up getting approximately 14.14, and just U for your unit. So with that being said, I want to show you another example. So the coordinates were given before, and the coordinates for A is simply 2, -1, and the coordinates for B is 4, 3. The coordinates for C is 2, 7, and the coordinates for D is -2, 3. All right, and I'm going to connect these for you, and then we are going to deal with this accordingly. You will notice in this case that this is not a rectangle. All right, so because it's not a rectangle, you can still treat it the same way. Either use the distance formula, or you can use the Pythagorean theorem formula. So because I already showed you how to use the distance formula, you can go back and watch my video on how to apply the distance formula to find the length of each measurement. But for argument's sake now, I'm simply going to enclose this figure into a box, and then we can apply the Pythagorean theorem formula to get the length of all the 4 segments, so that we can go ahead and find the perimeter of this given figure. So let's get into it and start off with enclosing this figure. So I have that enclosed, and I can also go ahead and label each one of these, because we have here 4 units, and then going across here, this is 2 units. This one we have 2, 4 going across, right? And then coming down, we also have 4 units coming down on the outside. All right, and this is 1, 2, 3, and 4. So here we have 2, 4 coming down and going across, 2, 4. All right, and then we have here, this is 2 going across by 4 coming down. So in essence, the entire figure here going across, this is a rectangle, right? And this is going to be 6 units going across, and coming down, this is 8 units coming down total. All right, because you come down to here. Not only that, how you can know, -1 to 7, that's 8 units, and from -2 to 4, that is 6 units going across. So it is a quadrilateral, but it's not a rectangle. We cannot apply the properties of a rectangle in this case because it is not a rectangle, right? So we cannot say that, oh, opposite sides are congruent. We can't use that, and we can't, because opposite sides are not parallel, hence opposite sides are not going to be congruent. So with that being said, let's get into, and I'm going to do the easiest one, which is to apply the Pythagorean theorem formula in this case. So let's get right into it. So we know that the formula that we're going to use is c squared equals a squared plus b squared. So we have segment A, B, which is our hypotenuse there, because you should know by now this is the hypotenuse and these are the two legs. So that square is going to be 2, which is, it doesn't matter, we're talking short leg and long leg. 2 plus 2 to the second power plus 4 to the second power. All right. Then segment AB square is equals to 2 to the second power is 4, and 4 to the second power is 16. Please do not tell me, oh, 4 to the second power is 4 times 2. No. 4 to the second power is simply telling you that you're going to multiply 4 2 times. All right. And that is going to give you 16. Please don't make that mistake. Segment AB to the second power is going to be 20, and segment AB is going to be square root of 20. You can further break down square root of 20 into simply square root of 4, which is the perfect square, and square root of 5. Segment AB now is going to be 2 radical 5. We are not done. All right, I'm just going to box this for now. We're not done. We have to find what segment BC is going to be. So BC is going to be using this measurement here, and we're going to use 4 to the second power plus 2 to the second power. And this is going to give us BC square is going to give you 16 plus 4. So segment BC to the second power is going to give you 20. So therefore, segment BC is going to give you radical 20, and you break it down, which is going to simply be 2 radical 5. Segment CD, this is 4 units over, coming down to 4 units here. So segment CD to the second power is going to be 4 to the second power plus 4 to the second power. All right, so segment CD to the second power is going to be 4, 4, 16 plus 16 is going to be 32. Segment CD to the second power is going to be 32, and segment CD is going to be radical 32. But you have to break that radical 32 down to radical 16 and radical 2. So now segment CD is going to be for radical 2. All right. And the last one, final one, all right, is going to be this one. And it so happens that, guess what? This segment here, which is segment AD and segment CD, they are going to be the same measure, all right? The same measurement. So, but that figure is not a rectangle, all right? Just want you to know that. So we are going to work on this, and we can say that segment AD is 80 to the second power is going to be, this is 4 times 4 here. So we have 4 to the second power plus 4 to the second power. Segment AD square is going to be 16 plus 16. AD square is going to be 32. So segment AD is going to be radical 32, which is the same as over here for segment CD, which is going to be equals to 4 radical 2. However, we can say that segment CD and AD are the same measurement, they are congruent, all right? But notice that also segment BC and AB are also congruent, but they are not opposite segments that are congruent, and hence that's the reason why it is not a rectangle, because the properties of a rectangle is that opposite segments are going to be congruent and parallel. So this is a quadrilateral, but it is not a rectangle. Hence we can now put all of this together and we can add these and come up with the perimeter of the object. Perimeter of, and we're not going to put rectangle, we're just going to put perimeter of ABCD is going to be 2 times 4 radical 2 plus 2 times 2 radical 5. Okay? And we're going to put this together. Perimeter of ABCD is going to be 4 2's is 8, 8 radical 2 plus 4 radical 5. Now, guess what? We cannot add these two together because they are not like terms. And if you need further help, you can go back and watch my video on how to add and subtract radicals. Now, because they're not like terms, you can leave your answer as this. Or if you decide that you want to simplify this, you will end up on your calculator, you will get 8 times radical 2. Radical 2 is 1.414, and 8 times radical 2 is going to be 8.94. Okay? So because you have 8.94, you're going to add it. Radical 5 times 4 is going to be 11.31. So it's going to be 11.31. When you put all of these together, you're going to get, I'm going to write it over here, perimeter is equal, which is 8.94 plus 11.31. And you put it together, you're going to get, the perimeter is going to be, this is going to be a 5 here, and this is going to be a 2. So this is going to be 20.25 units. All right, and that is your answer for your perimeter. So in conclusion, now that you know how to find the perimeter of a quadrilateral that you were only given the coordinates, no measurements, I hope that this video has helped you tremendously, and you now know how to either apply the distance formula or you can apply the Pythagorean theorem formula. But remember that if you are applying the Pythagorean theorem formula, you have to enclose that figure into a box and use each of those segments as the hypotenuse. And remember, it's all going to be a right triangle. And so the side length that is opposite the right angle is going to be your hypotenuse. Since I gave you these two examples of the quadrilateral, it doesn't mean that each quadrilateral is going to be a rectangle. You notice that the first one that we did, yes, was a rectangle, but this second one, it was not a rectangle. However, 2 pairs of the segments of this quadrilateral are congruent, but they were not opposite each other. They were side by side each other. So this is the reason why this is simply going to be classified as a quadrilateral, and the other one you will classify it as a rectangle, because 2 of the opposite sides were congruent. All right. So if you have not yet subscribed to my channel, what are you waiting for? Go ahead and hit that subscribe button. And if you like what you see, hit that like button also and share this video with others around the world so they too can be successful and know how to find the perimeter of a given figure without any measurements. So thank you for watching and see you soon on the next video to come. Bye now. Cheers.